VLAN trunking protocol is our today's topic, but before that, we are going to see the different types of ports that you can have on a switch. You may have an access port or a trunk port. There is no other type. But modes of port, we have again access, trunk, auto, dynamic, desirable. Right, this can also be called as on mode. Now, we'll talk about the modes a bit later. Push it down. Now, what is access port? When you take a switch, all ports by default will be operationally access. That's why you no need to configure access. Operationally, each port will be access. The access ports cannot carry multiple VLAN traffic. Access port belong to single VLAN. So, whenever you want multiple VLAN traffic to be carried, say for example, I have connected another switch to this switch. Then I'll be using one of this port. I can ping anywhere. It need not to be this first port and first port. But as a practice, what people do is they connect the first port to first port, but not mandatory. There is no logic. See, that is hygienic, not logic. Why I call it as hygienic? So that blindly you will know, you can tell anyone, hey, first port don't touch, it's a trunk port. You can easily tell someone what to do. Otherwise, what you will do, you will say, hey, go and check, man. Go and check which one is connected to the other switch. And that port need to be a trunk port. You don't need to do those unnecessary explanation. If all the switches that you're connecting back to back like this, connected to the same number of ports. For example, if I'm connecting this and this, then I'll connect to this one. Like this is F0/2. Here also F0/2. F0/1. Here also F0/1. F stands for fast Ethernet. The port that will work in 100 meg speed. Now, this is a kind of good practice, but it is not a mandate. It is not like only if you connect like this, it will work. No. You can take F01 of switch 1 and connect to any port in switch 2. Now, what I'm trying to say here is between these two switches, you may need a trunk port if some of these ports are VLAN 10 and some other ports are VLAN 20. Now, all these 20 can talk to this 20 through trunk port, and all these 10 VLAN members and all these 10 VLAN members can talk through trunk, which we saw earlier in our VLAN class. Now, only when we are configuring a port as a trunk, you need to you have to configure this. By default, all the ports will be operationally accessed. They're operationally accessed. So when you connect a wire like this back to back, they are not going to be a trunk port. So the link also will not be a trunk link. If you want a trunk link, what is a trunk link? A link that can carry multiple VLAN traffic. Means any wire can carry multiple VLAN traffic if they are connected to a trunk port. So what makes a link to be a trunk link? The port. If the port is a trunk port, then the link connected to the port will be a trunk link. So don't imagine that we have a special wire for trunking. No, no, no. There's no need for special wire. Now, trunk need to be configured. Which is not by default. Now this trunking means what? We saw multiple VLAN traffic it can carry. But if a computer here talking to a member of the same VLAN, the other computer is in same VLAN, if A is talking to B, the packet will be simply forwarded like this. Because they belong to same virtual switch. But if A is talking to C, though it is a member of same VLAN, it needs a tag. Why? When the packet goes through the trunk port, the receiving switch needs to know to which VLAN I have to forward. Should I forward to this pink VLAN or to the blue VLAN? Confusion. So there is need for a tagging. Yeah, the trunk ports will tag VLANs. So before sending the traffic out on the trunk port, the switch is going to say, hey, this belongs to the pink VLAN. Let's say pink VLAN is VLAN number 10. So if this is the packet, it's going to add VLAN 10 in layer 2 header. So when this packet goes to the other end of the wire, the receiving switch will see the VLAN number, and the receiving switch will know now I need to forward to this domain, not to the other blue one. After knowing this, the receiving switch, what it will do, it will pop the label of, it will pop the VLAN ID. After knowing, it will simply pop the VLAN ID. After knowing that it belongs to VLAN 10, it pops the VLAN ID and delivers the packet to this domain members. So why do we need to tag? In order to make known to the receiver to which VLAN this packet belongs to. The tagging, adding of VLAN ID to the packet that leaves the trunk, can be done in two ways. That marking, the tagging, it is done in two ways. And that depends on what tagging protocol you are using, what trunking protocol you are going to use. What trunking protocol you use? What is trunking? We just saw. Trunking is a link. Trunk link is a link that carry multiple VLAN traffic. For that, trunking is needed. What is trunking? Adding the VLAN ID before sending the traffic. On the receiving side, reading the VLAN ID, popping the VLAN ID out, and delivering the packet to the correct VLAN group, correct broadcast domain, correct virtual switch. That is trunking. Now, for this, there is a protocol. There are protocols like ISL and dot one Q. Actually, dot one Q is the name of the protocol, but the name why they have given like that is because of this one. So the standard, IEEE standard, explains the trunking. So they want to name this standard, but they didn't get any good name to keep. At last they said, okay, let's give this name, dot one Q. So the protocol is named as dot one Q. Dot one Q. என்னப்பா பேர் வைக்கிறது என்னப்பா பேர் வைக்கிறது என்னப்பா பேர் வைக்கிறது இவனுக்கு அறிவு நிறைய வேணும் அறிவழகன் கண்ணாயிரம். Likewise, they were confused what to name it. At last they said, okay, let's call it as DOT1Q. This dot 1Q. So that easy to remember even the IEEE standard now. If I ask you, what is the IEEE standard for MST? Do you remember? It is IEEE 802.1S. It's difficult to remember, you see. But this you no need to remember. Name itself is dot one. This is one protocol. There is another protocol doing same tagging job, tagging of VLAN before sending the traffic out over the trunk link. It is called ISL. This is by Cisco. This ISL stands for Inter Switch Link Protocol. Inter switch link. See, it is in between two switches. The link needs this protocol, isn't it? In between switches will be mostly a trunk link. Why? Because in a switch we will have more than one VLAN. If I don't have more than one VLAN, if I have only green everywhere, you no need this to be a trunk link. Not necessary. If all the ports of both the switch belong to same VLAN, you no need trunking. Trunking is needed whenever you got more than one VLAN on a switch. Most of the time in the real world, we have many VLANs in each switches. And when you connect between the switches, the link needs a protocol to tag the traffic before sending it out so that receiving switch can know to which VLAN the packet belongs to. Cisco came up with their own protocol called Inter-Switch Link ISL. An industry standard equivalent protocol is .1Q. I was telling you this tagging can be done in two different ways. And I told you that depends on what protocol you are going to use. If you are using Cisco, there is a way. If you are using industry standard protocol, There's another way. Both may give you same result, but both are not done in the both are not done the same manner. I remember I boarded into a flight called Peace Airline. Peace. Wow, there's an airline called Peace. I'm going to fly in that airlines, which I never been before in this airline. Wow. I was in the queue, got into the flight. I was sitting there with tall people, very strong and tall people. And I was the one very small in size. And then through the window, I saw many are not getting inside the flight. I have got inside the flight. Many are still outside. They're supposed to be before me, but they are still outside. Oh, what is going on? And after everyone loaded, I saw one box, and that is my box, still lying on the ground. I checked in. I put it in the baggage, but they did not load my baggage inside the flight cargo. I saw my baggage alone staying in the ground, but everyone's baggage just went inside. Then I realized, in this country, before you enter into the flight, you need to say, "This is my baggage. Please take it inside." Only then they will keep inside the cargo. That's not most of the country practice. Most of the country, during the check-in time, you just put the check-in baggage and they take it to the flight, and you see that baggage only after you land in the destination, if it is same carrier for the connection flights. But this was surprisingly different for me. You see, the same work, I gave my baggage during the check-in time, but they are not going to put it in the flight. They do in a different way. They bring it to the flight entrance. After you identify your bag, only then it gets into the flight. It gets into the flight. And then after landing, it will be there in the belt as usual. You see, the way that they do that is different. I don't know the exact reason. That it may be because in that country, people carry guns. People carry guns. So if you have guns inside the check-in baggage, when you identify your bag before entering into the flight, they may arrest for keeping gun inside the flight, inside the baggage. Actually, you can carry gun in that country, but you need to hand over it uh, by removing all the bullets. And like you get your baggage on the landing place, final destination, gun also will be given to you after you produce all the necessary documents. Anyway, so you see, it's not a usual way of check-in baggage handling. It's different. Likewise, the VLAN tags, the VLAN numbers are added in ISL by encapsulation. By encapsulating with the header, additional header in layer 2, an additional header is added in which the VLAN ID will be seen. Whereas in .1 queue, no additional header, no encapsulation, just a field. of 4 byte. In your layer 2 header, an additional 4 byte field is created in which the VLAN is marked. Let me draw and explain. If this is your packet and this is your layer 2, how ISL do? It adds another layer here, which is of 32 bytes. Whereas .1q just adds additional field of 4 byte in the same header. It is just 4 byte, but this is 32 byte. Too bad, too bad, too bad. See, when a packet moves from this switch to this switch, the switch needs to process for every single packet 32 bytes if you are using ISL. If you are using .1q, it is only 4 byte. Tell me which one is good? This is good. Every single packet 32 byte is bad. Almost 8 times more CPU. You see? So Cisco has removed it from most of the switches. This option is no more available. But yesterday you might have seen me when I was doing lab, I told you in packet tracer you no need to say encapsulation using .1q. But in some switches you need to say this. The reason is that the switch may also have support for ISL. If a switch has got support for both, then you need to mention which method you want to use before configuring trunk. Go back to the previous video and see what I'm saying. It will be well understood. Yesterday, while I was configuring a trunk port, I was giving a command called switch port trunk encapsulation .1q, and then I said switch port mode trunk. The reason is that switch has got support for both ISL and .1q. You need to mention which one you want to follow. Whereas in packet tracer, only .1q is supported, so you don't need to mention that. You can simply say switch port mode trunk. Did you understand what I said? Great. So, trunking protocols, though we got 2, what is practiced in the real world is .1q. Reason is, first reason, it is an industry standard protocol. I can have a Cisco switch and I can have Juniper switch. No problem. Because I'm following an industry standard encapsulation. If I need to use the ISL, then both need to be Cisco. Because Juniper don't understand ISL. That's a drawback. This is a main drawback. Main drawback. It's a proprietary. Another drawback is this: 32 byte. 32 byte instead of 4 byte. 32 byte is 8 times more. 7 times more processing for each packet. A result is same. What it is? you are going to know what VLAN the packet belong to. If you read this 8 byte, sorry, if you read this 4 byte, you get the same info that you get after reading the 32 byte. And why the 32 byte? Let's go with 4 byte. Easy, no? So .1q is best. All right. Now, if you're configuring trunk link, sometimes you need to say what protocol you want to follow because it has got both the options ISL and .1q. Now coming back to this again as a revision, let's do it. A port will be by default an access port. It will not be tagging the VLAN numbers before sending. Between the switches, if you want to pass multiple VLAN, then you have to tag the VLAN and say this is the VLAN the packet belongs to. For that, you have to configure trunk port. Any port can be made as a trunk port. Just the command is what makes that port trunk port. There is no special cable or port type. There is no special size of a port or color of a port. Any port can be connected with a wire and made as a trunk. See, sometimes people will make this port as a trunk port. You know why? Because they have VMware inside. Inside they will have a virtual switch. Same like this, there will be a switch inside this VMware, ESXi. So that virtual switch will be tagging the traffic and sending it out using same .1q. Inside this one computer, you will have 20 computers, maybe 20 PC, virtual PC in different VLANs. So in that case, even though it is connected to a computer, it is not really a computer. For you, it is a computer. But inside there is a hypervisor, a thin operating system sitting on Linux or whatever, a kernel, they're sitting on some kernel through Linux or whatever. On top of which you have a lot of VMs. And each VM may be a member of different VLANs. So you'll be creating VLANs in this virtual switch. So the only wire that goes out from your server, a NIC card, from the NIC card is a trunk. It need to be a trunk. Okay, so let's not get into that. That's not our area. I'm just explaining that you may see a trunk port, though it's connected to a computer, because the computer is not a computer. They have made the computer to be a ESXi server. Okay, now what is next? Let us get into the port modes. Port modes. I was using a word operationally, which means there is another word called administratively. Administratively, operationally. What is it? By default, if you take a switch, the port on the switch will be administratively auto. Administratively auto. And operationally access. What does that mean? If a port is administratively auto, that port is available, ready to be a trunk as well. I repeat, I live in India, but I'm flexible. If I get a L1 or H1 or whatever visa, I'll move to US. Operationally, I am in India, but I'm not stubborn. I'm flexible. That is what auto means. Auto is not stubborn saying, India is my country. Nah, who cares? Same heaven, but better atmosphere. Where? Outside India. Then why I will be stubborn? India is my country. Who cares? Full pollution, corruption, no respect for education, no value for truth, honesty. So administratively, I'm flexible. I'm auto. At any time, if someone says, I give you visa, come, then I'll say, no more India, my country. Bye-bye. That is what administratively auto. The port is not stubborn saying, I will be only access. I may become a trunk if someone comes and negotiates trunk. That is the state of that port. By default, on Cisco switches, every port will be administratively auto and operationally access. But when you have another switch, connected to this switch 2, sorry. Now, when I have switch 2, I make administratively, by default, it will be auto. I say, no, no, no. I want the port only to be trunk. I want it to be a trunk. You know what is trunk? It will tag VLANs. It will carry multiple VLAN traffic. So administratively, I'm going and changing it. By default, when you don't change it, it will be auto. This one. Now I'm going and owning the trunk by saying you are a trunk. Administratively, trunk. So operationally, it cannot be a access now. Not only that, a negotiation packet goes to the other end saying, hey, I'm a trunk. What do you say? And this guy will say, oh, very well. I'm an auto. Administratively, I'm an auto. You want me to be a trunk? No problem, man. I'll join you. See, this is trunking now because of negotiation. But here this is trunking because I have turned on the trunk. Both are trunking, but the reason is not the same. Here, I administratively tuned, configured, saying, thou shall be trunk, no more access. So immediately it says, okay, fine, Roger, sir, I'm a trunk. Not only that, it goes to the neighbor and say, you see, I'm a trunk. I cannot be a successful trunk unless you support me. What do you say? And the neighbor says, oh, no problem. I'm an auto. I'll support you. Let me turn myself as a trunk. So operational mode switches from access to trunk because of negotiation. So now you should have known what is access, what is trunk on, what is trunk negotiation, what is auto. Any question other than the last dynamic desirable? I have finished all other. Do you have any question? Okay. Let's see what is dynamic desirable now. You see, this port, administratively now I made it as access. So operationally, it will never become trunk. Why? Administratively, I have made it as access. Operationally, it will never switch to trunk. This side, if you configure administratively trunk, operationally, this cannot be access. This will say trunk only. Now, if the negotiation packet goes there to switch to, will switch to agree to form a trunk? No. Why? Administratively, it is hard coded to be an access. So what will happen if any conversation goes problem? Why? This guy will tag and send the traffic. This guy will never read the tag because it's not a trunk. This guy will send without any tag. All untagged traffic will get dropped here because trunk port needs a tag. I repeat. This is connected to native VLAN that you asked me yesterday. A trunk port accepts a packet if it comes with a tag. I repeat, a trunk port accepts a packet if it comes with a tag. Now, what is native VLAN? On the trunk port, you can configure a native VLAN, let's say 80, native VLAN 80. What does that mean? If any packet comes without tag, they belong to 80. That's the meaning. That is the scenario where native VLAN is needed. I repeat. Trunk ports accepts packet that comes with some VLAN ID. But there may be a situation where you want the trunk port to accept some traffic even though it is coming without a VLAN ID. In such cases, you need to decide to which VLAN those untagged traffic you want to put. For example, VLAN 50. I want all the untagged traffic to be placed inside VLAN 50. So you can go to the trunk port and configure native VLAN 50 so that any traffic come without tag will be put into 50. Only one VLAN can be configured as native VLAN. Did you understand what is native VLAN? Is native VLAN and default VLAN same? No. But why yesterday when we saw the native VLAN was what? because by default, you don't have any other VLAN other than VLAN number 1 on any switch. So you need to go and put the exact native VLAN that you want. Otherwise, for namesake, they will put 1 there. Okay. Now, coming to this point, dynamic desire. Look at this. There's a big confusion here. This link is not a trunk link now because one end is access, the other end is trunk. For becoming a successful trunk link, both the end need to be trunk. How do you solve this problem? For that, we go with dynamic desirable. When I configure dynamic desirable, operationally it will be access, but it will go and tell the other guy, hey, my friend switch 2. Switch 1 will say, my friend, hey, switch 2, listen. Actually, my desire is to form a trunk. My desire is to form a trunk. What to do, my fate? I'm an access now. If you will support trunk, I can switch myself as a trunk. What do you say? Based on your approval only, I am going to decide whether to be a trunk or access. So it goes and negotiates. So it won't immediately switch to trunk. It will go and negotiate if the other guy supports to form a trunk. If other guy says, okay, let us be a trunk, only then this can be a trunk. Otherwise, it will continue to be an access. Why here it is continuing to be access? Your switch 2 is not ready to support trunk. Why? Because the administrative mode is access. If in case this is auto, now this negotiation comes, my friend. Right now I'm in access mode, but I want to be a trunk. I'm a desirable. My desire is to form trunk, but for that I need your support. What do you say? And switch 2 says, oh my poor friend, don't worry, I'm there. No, I'm just an auto. You see, I'm flexible. For you, I'm changing myself as trunk. And immediately this guy says, thank you, sir. I will also change myself as a trunk. You see, both the side it is trunk because of negotiation. It is not on mode. Both are negotiation. N. This side it would have not become trunk if other side is unsupportive. Dynamic desirable will make operationally trunk only if opposite party agrees. If opposite party is hard-coded as access, dynamic desirable will stay as access. You understood this? All the modes, on mode, auto mode, dynamic desirable, access. All right. And now ISL.1Q. ISL stands for interswitch link. .1Q is IEEE standard protocol for trunking. So how many protocols are there for trunking? 2. Which one is currently in use? .1Q. Now, if you have understood this, you can go for the next topic called VTP, VLAN trunking protocol. This is the reason why I took the modes before I teach this, because this is something called VLAN trunking. Come on, what is this doing? Oh, VTP. VLAN trunking protocol. So a word trunking is coming in this topic. That's the reason why I took this modes first. Right, but because it's time up today, we'll continue this VTP in our next class. Hope you enjoyed today's class. If you have any question, you can ask me now. All right, then. See you tomorrow. Have a nice evening. Bye bye.